Hey guys, we're going to do the practice test for chapter 5. So make sure you get a piece of scratch paper, right? Because you'll need to show your work on another piece of paper. So question 1 says, this question has to do with question 1, 2, and 3. And we'll refer back to these same facts. A group of 125 truck owners. So let's see what that is. 32, 20. Right, 17, 18, 10. So that's 45, 50. And so this is where they're getting their number, is the grand total, right? Okay. So this is the ones that said yes. This is the one that said no. This one said Ford, Chevy, and Dodge. So it says they interviewed them and asked what truck they owned and whether or not it has four-wheel drive. The results are summarized in a two-way table. So it says, what is the probability that a person owns that a person? So we know the denominator is 125 because we talked to 125 persons. What's the probability that a person owns a Dodge, okay, owns a Dodge, or has four-wheel drive. So that's these 30 plus these. So using our formulas, it's the probability of a Dodge plus the probability of yes, four-wheel drive, minus the probability of both. So that's 80, Dodge. 30 out of 125 plus 80 out of 125 minus the overlap of both a Dodge and, all right. So that would be D, 90 out of 125. How would I do it? I typically think of it as people. So these 28 said, yep, four-wheel drive, yep, four-wheel drive, yep, four-wheel drive. These people said, yep, Dodge. So those are all the people that said four-wheel drive or Dodge. So I typically would add up those and you get the same answer. I do it that way, though, because I don't have to memorize any kind of a formula. Question number 2. What is the probability that a person owns a Chevy given that the truck has four-wheel drive? So given that the truck has four-wheel drive, so we're only talking about the 80 people, given that they four-wheel drive. So it's probability given they have four-wheel drive. What is it that they own a Chevy? Okay, so how many people of these 80 do a Chevy? These 32. All right, so we see our answer is B. B as in boy. All right, question number 3. Which one of the following is true about the events? Owner's truck is a Chevy. Owner's truck has four-wheel drive. Okay. Are these mutually exclusive and are they independent? Okay, so mutually exclusive means they can't happen at the same time. All right, so that would be the probability of Chevy and yes, four-wheel drive equals 0. That's if it's mutually exclusive, then this would be the case. So what is the probability of Chevy and four-wheel drive? It is not 0. The probability of Chevy and yes, four-wheel drive is 20 out of 125. So this is not mutually exclusive. There is an overlap. So we say this is not. These two events are mutually exclusive. No. These two events are neither, okay, that's a possibility, are mutually exclusive. Okay, so now we just have to figure out if they are independent. So what does independent mean? that would mean that the probability of A is equal to the probability of A given B is equal to the probability of A given not B. So let's figure out what that means. They're saying, does the probability of owning a Chevy equal the probability of owning a Chevy given you have four-wheel drive, and then also equal to the probability of Chevy given that you're not four-wheel drive, so that would just be no. I could put YC. Okay, so what is the probability of Chevy? It looks like that's 50 out of 125. All right, what's the probability of Chevy given that you said a yes? So Chevy, given you said a yes, 32 over 80. We already found that out in this question. And then the final one, what's the probability of Chevy given you said no? So that'd be 18 out of 45. 18 out of 45. So we're wondering, do all these numbers equal each other? Okay. Or we could also cross multiply and solve. So if I multiply these two, I get 50 times, that's be 4,000. Is this 4,000? And again, any way is fine. So if I go to my calculator setting, where's my calculator setting? Here it is. I'm here, but now I've forgotten what I'm going to calculate. So let's go back. What am I going to calculate? Yeah, what's 50 over 125? 0.4. What's 32 over 80? 0.4. Oh, interesting. All right, and what's 18 over 45? 0.4. Aha, so we can say this is yes, independent. So I have no better or worse chance of guessing if I know you have a Chevy. It doesn't help me in knowing whether you have four-wheel drive or not, because it looks like 40% of these people have a Chevy, 40% of people with Chevy do have four-wheel drive, and actually 40% of people who don't have four-wheel drive have a Chevy. So it's all the same. So they are independent. So we're going to pick C. All right, question number 4. A spinner has 3 equally sized regions, blue, green, and red. Okay. Equally sized regions, blue, green, and red. All right. Okay, blue, green, and red. The spinner has 3 equally sized regions, blue, green, and red. He spins the spinner 3 times and gets 3 blues in a row. Okay, so that's the probability of blue, right? Because there's 3 spaces. And then 3 in a row would be 1 out of 3, and 1 out of 3, and 1 out of 3. 3 in a row. If he spins the spinner 297 more times. So let's clean this up a bit if we're going to get to really big numbers. So this would be the probability of blue 3 times in a row. Okay. Now it says if he spins the spinner 297 more times, how many more blues is he most likely to get? Okay. So when you spin each time, regardless of whatever you just got done getting, the probability of spinning a blue is the same. It's going to be 1/3 no matter what. So we see here, how many times should we expect? Well, what is 1/3 of 297? Okay, so a third of the time. So a third of the times I'm going to get that. So if I go to my calculator, 297 divided by 3 is 99. Cool. Okay, so a third of the time I'm going to get a 99. So if I spin it 297, 99 times I'm going to get blue, about 99 times I'll get red, and about 99 times I'll get green. That's what I'm predicting. Cool. Watch the next videos for some more multiple choice.